Hi everyone, in this video, as I promised, I'm going to give you another definition for sine, cosine, and tangent that will always work, no matter if the angle is part of a right triangle, or if it's obtuse, or if it's a totally weird angle that you might never know how to evaluate otherwise. This method will always work, and we'll practice it in class. So, here's how we define it. Theta is a real number. It's representing an angle, and x comma y is going to be the point on the unit circle corresponding to theta. So let me tell you how to figure out that point. Unit circle just means radius 1 and center 0, 0. So first we draw our unit circle centered at the origin, and since it has radius 1, we know that this length is 1, so this point is 1, 0. Now I'm going to move counterclockwise from the x-axis theta degrees. So in this case, maybe theta is about 45 degrees or pi over 4 radians. And I look at the end of that radius where it ends on the circle, and that gives me a point. So I go theta and look at the corresponding point on the circle, and that's going to have some coordinates, x comma y. So now the way that I define cosine, sine, and tangent is just saying, well, let cosine be the x-coordinate. So cosine of theta is just this x value. Sine of theta is just the y value of this point. So another way that you can think about this set of coordinates is just cosine theta, comma, sine theta. So if I picked a different theta, maybe I have an obtuse one now. So I go a new, let's call this one theta 2 to represent that it's a different angle. So now I've gone this far. I draw the radius in. Here's my new point. It has different coordinates. So this will be x2, comma, y2, different values for x and y. And so x2 is cosine of theta 2, and y2 is sine of theta 2. And you might notice that if theta is acute, then both x and y are positive, which means cosine and sine are positive. But for theta 2, which is an obtuse angle, the x-coordinate's on the negative side, so cosine of theta 2 is negative, and sine of theta 2 is still positive. So now I can figure out how to find tangent. We know that tangent is the same as sine theta over cosine theta. And so tangent is just going to be, since sine of theta is y and cosine theta is x, tangent is just going to be y divided by x. So let's do a few examples in very easy cases to make this make a little more sense. All right, so my first goal is to find cosine of pi over 2, sine of pi over 2, and tan of pi over 2. So my first step is to start at the x-axis, move an angle of pi over 2, so that's the same as 90 degrees. So this is the angle that I'm looking at. And so this is the point I'm interested in, the point on the unit circle that corresponds to pi over 2. So what I need to figure out are the coordinates of this point. And I know it's a unit circle, so this radius is length 1. So my x-coordinate is 0 because I'm on the y-axis. My y-coordinate is 1 because I've gone 1 up to get there. So what that tells me is that cosine of pi over 2 is the x-coordinate is 0. Sine of pi over 2 is the y-coordinate, it's 1. And tangent is sine over cosine, or y over x, so that would give me 1 over 0, which is undefined. So let's do another simple example. If I want to know cosine of pi, sine of pi, and tan of pi, I start at the x-axis. I move an angle of pi, which is halfway around the circle. So this is the second radius I'm interested in, so this is my point x comma y. It's a unit circle, so I've moved 1 in this direction, which means I'm at my x-coordinates -1. My y-coordinate's 0 because I'm on the x-axis. So that tells me that cosine of pi is the x-coordinate, which is -1. Sine of pi is the y-coordinate, which is 0. Tangent is going to be sine over cosine, so 0 over -1, and that is just 0. So tangent of pi is 0. 2 more quick examples. To get cosine, sine, and tangent of 3 pi over 2, well, if this is 1 pi over 2, 2 pi over 2, 3 pi over 2, then I end here. So this is the point on the unit circle that corresponds to 3 pi over 2. It has coordinates. Well, let's see, did I go any way along the x-axis? No, so the x-coordinate 0. Along the y-axis, I've gone down 1, so the y-coordinate is -1. So cosine is the x-coordinate. Cosine of 3 pi over 2 will be 0. Sine of 3 pi over 2 will be the y-coordinate, so that's -1. And tangent is going to be the sine over the cosine, which gives me -1 over 0, which again is undefined because I can't divide by 0. And finally, this one might seem a little tricky, but it's actually the easiest one. To find cosine, sine, and tangent of 0, it means start at the x-axis, but go 0 radians, so I don't go anywhere. So I end here. So what are the coordinates of this point? Well, I've gone 1 in the x direction and 0 in the y, so it's 1, 0. That tells me cosine of 0 is 1, the x-coordinate. Sine of 0 is 0, the y-coordinate. And tan of 0 is 0 over 1, which equals 0. In class, we'll use this strategy to find the sine, cosines, and tangent of more interesting angles, but it's important to know these four that lie on the axes because they're particularly nice and easy values of cosine and sine. A couple more things that you might notice are that in this quadrant, cosine is positive and sine is also positive because both the x and y values are positive. In this quadrant, cosine is negative and sine is positive. In this quadrant, because x values and y values are both negative, we have cosine is negative and sine is negative. And in the fourth quadrant, we have positive x's and negative y's, so cosine is positive and sine is negative there. So that's just one example of some observations that we can make about cosine and sine based on this definition, thinking about it in the unit circle. You might also notice that no matter what angle I pick, both cosine, the x-coordinate, and the y-coordinate are less than 1. The biggest values that those could take are between -1 and 1. So we also learned that cosine of theta is always going to be between -1 and 1. And the same is true for sine of theta, because on the unit circle, my x and y values can't get bigger than 1. So that's another important observation that this geometric idea of sine and cosine will help us to understand. Okay, so good luck with the web work, and let's talk more about this in class. See you soon.